Hi, welcome to part 4 of the video series about work and energy. In the previous video, we learned how to calculate the work done by the force of gravity on objects that are moving either vertically or horizontally. But just as life isn't all black and white, neither is the direction of motion. Things don't only move left to right or up and down. They may also move at an angle to one of these directions. In this video, we will learn how to calculate the work done by gravity on objects that slide up or down an incline. Calculate the work done by the force of gravity to pull a 5 kg box down a 42 degrees inclined plane of length 6 meters. Let's start by writing down the work formula as the first step in the solution. We must specify the values of force and theta before moving forward with substitutions. Drawing the diagram that illustrates the conditions in the question will help us to achieve this. A 5 kg object is sliding down a 42 degree incline for 6 meters. As usual, force of gravity pulls the object downwards. At the same time, the object's displacement is parallel to the inclined surface. There are several different ways to move forward from this point. In the following question, we will learn about one of these methods. For this one, we will begin with a step we are already accustomed to from what we have learned in previous sections, splitting the gravitational force into its components. We can ignore the perpendicular component because its work will be equal to 0. If you are wondering as to why, you can watch the previous video. Since the parallel component of gravitational force acts in the same direction as the displacement, the angle between them is equal to 0. The work formula can now be adjusted to be the parallel component of gravitational force multiplied by displacement and then multiplied by cosine theta. As we saw in the lesson on the laws of motion, the parallel component of gravity is equal to the product of mass, gravitational acceleration, and sine of the angle of incline. Let's be careful to distinguish between these two angles once more. In this example, the angle between the force and the displacement is 0, and the angle of the incline is 42 degrees. The object has a mass of 5 kg, a gravitational acceleration is 9.8 meters per second square, and displacement is 6 meters. The amount of work done by the gravity is 196.72 joules. The next question is pretty similar to the previous one. The only change is that instead of specifying 6 meters as the object's displacement, it is now stated as the height of the incline. We will discuss two methods of solving this question. The first option is very similar to the answer to the previous question. First, we write down the formula of work. Next, we draw the diagram. However, now 6 meters is representing the height of the incline. Force of gravity is acting downwards. One of its components is perpendicular to the surface, the other one is parallel. As object slides down the incline, the direction of displacement will be the same as the direction of FG parallel. We adjust the formula such that work is equal to parallel component of force of gravity multiplied by the displacement multiplied by the cosine of theta. Since the displacement is not specified in the question, we must calculate it. We know that the sine of an angle is equal to the ratio of the opposite side to the angle, which is height for this question, and the hypotenuse of a triangle, which represents the displacement. In this case, sine 42 is equal to 6 over displacement. After some refactoring, delta x is equal to 6 over sine 42. The displacement of the object is equal to 8.97 meters. FG parallel can be written as mass times gravitational acceleration times sine of angle of incline. Mass of the object is 5 kilograms. Gravitational acceleration is 9.8 meters per second square. Angle of incline is 42 degrees. Displacement is 8.97 meters. and the angle between FG parallel and the displacement is 0 degrees. Work done by the force of gravity is equal to 294.1 joules. We mentioned at the beginning that we would approach the problem using two different methods. The second option we will use is not much different from the previous one. However, by using it, we will avoid calculating the length using trigonometry, and more importantly, we will only have to deal with one angle, which will make things easier. While describing this strategy, we will include a few extra steps that are not included in the exam question solutions. These steps are only given for clarification purposes. Again, we begin the solution by writing down the work formula. Next, we draw a diagram that allows us to quickly and easily see all of the given values. The object has a mass of 5 kg, inclined angle of 42 degrees, and an incline height of 6 meters. Then, we sketch the force of gravity and split it into its components. The direction of the object's displacement is the same as the parallel component of the force of gravity. Therefore, the angle theta is equal to 0. We adjust the formula so that work is equal to mass times the gravitational acceleration times the sine of the incline, multiplied by displacement and then multiplied by the cosine of the angle between the force and displacement. This is because the perpendicular component of the gravitational force is not doing any work. These steps are exactly the same as in the previous method, but now we will take a different approach. Rather than calculating the displacement of the object, we will refactor the term sine alpha. As you know, the sine of an angle is equal to the ratio of the angle's opposing side, that is the height of the incline, to the hypotenuse, which represents the displacement of the object. As displacements cancel each other out, we can now simplify the formula. The work of gravity can be calculated using the following formula: mass times the force of gravity multiplied by the height of the slope multiplied by the cosine of theta. Mass of the object is 5 kgs, gravitational acceleration is 9.8 meters per second square, height is 6 meters, and theta has already been identified as 0 few steps ago. Work done by the force of gravity is 294 joules. The results of the two methods vary slightly. The reason for this is the rounding that we used while calculating the displacement using the first method. Why did we bother to learn this method, which appears to be considerably longer and complicated? This is a result of the extra steps we took to provide an explanation. It will be greatly simplified if we only highlight the exam required steps. In the exam, we only need to write the work formula. After that, we can omit the first 3 steps and only write the remaining 3. The only decision to be made in this case is theta, which is also not difficult to do, since it will be given one of the two values. Gravity always pulls downwards. Therefore, theta will equal 180 degrees if the item slides up and 0 if it slides down. In this video, we learned how to calculate how much work the force of gravity is doing to move an object along an incline. Up to this point, we have calculated the work done by individual forces. We will discuss how to calculate the work done by 2 or more forces in the following part. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.